remember we had a cubed plus b cubed, which was a plus b. So just write the a and b down again. Then we'll have a squared minus ab plus b squared. That's the sum of cubes. And then when we had difference of cubes, a cubed minus ab, minus b cubed is a minus b, a squared plus ab plus b squared. So remember how to remember the sign. So this is plus, this is the same sign, minus, minus, and then this will be opposite. So plus here becomes minus, and minus becomes plus. And the last two are positive plus. Remember we had same, opposite, and all positive here, positive. All positive, so get rid of that. More coming. Okay, so same, opposite, all positive. So that was SOAP, S-O-A-P. So we've done this rule already, except we're going to apply that when we have higher powers. Okay, so we're going to use the same rule, but for these questions that have higher powers like 6 or 9 or 12, something like that. So in this case, we've got x6, 216z cubed. So we try to make these in the form of having power 3 here, either this one or this one. So in this case, this is plus. So I'll be using this one here because it's plus. So we've got x6. So well, that would be x squared cubed plus 216, which is 6z cubed, like that. It's in your textbook. You can follow along. So now we have a cubed plus b cubed. So we could write that underneath. A cubed plus b cubed. So that's just going to be a plus b. A squared minus ab plus b squared there. So we can write in the answer in the top. So a plus b, that would be x squared plus 6z. There. And then we have a squared. Well, x squared will be x4 minus a times b. So x squared times 6z. So make that 6x squared z. I'll put the 6 in the front. And then the last number squared. So 6z all squared would be 36z squared. Like that. And that's your answer there. Just put it in green. Yeah, that's it. So your key here is just to change your power to 3. 6 cubed, 216, z cubed from here and here. Those two parts. So turn them into power 3 in this case. So further down. So now we've got 64, A6, B6. Now, when there's power 6, now I'm going to follow what they've done in the book, but actually there's a better way to do this question. And that's using difference of square, not cubes. But we'll follow what's in the book anyway. So let's follow the book first, and I'll show you another way that's actually better to do this one. So you've got 64, A6, B6. So that's going to be 4 a squared cubed. 4 cubed is 64, okay? And 2 3s are 6. Minus b squared cubed here. Okay, so now we've got a cubed minus b cubed. I'll write that here. So you've got a cubed minus b cubed, and your rule is a minus b. And then the sign will become positive. So a squared plus ab plus b squared here. Okay, so it will help you to write the rule underneath or on the top. On the top may be better. So then we just follow along. A minus b. Well, that's 4a squared minus b squared. And we can actually do something with this part here. Then we've got a squared, which will be 4a squared squared. I'll write it here. That would be 16a4. So this is 16a4 plus ab, 4a squared b squared, plus b squared squared. So b squared is b4. So we'll put that there, b4. Not quite finished yet, because you can see you can actually factorize this again using difference of squares. So we'll do that down here. So 4a squared can be made 2a all squared, right? Minus b squared. And then this will be the same. Actually, this can be factorized. This is a special case, and I'll show you why in a minute. So this lesson is actually going to I think it's going to take 2 periods. So this week and next week, because I've got a little bit to talk about. 4a squared b squared plus b4, like that. So this is a difference of squares. So now you have the rule a squared minus b squared is a minus b, a plus b, like that for this first bit. So this is written again here as a difference of squares. And the second bit, we'll just copy down. 16a4 plus 4a squared b squared plus b4. Okay, that's the answer that they actually provide in the textbook. I'm not even sure they show this bit. I'd have to check. So that bit is here. Okay, that bit was actually yellow, so I guess we can fix the color. Come on. I want to change the blue to yellow. Anyway, never mind. So that's the answer there, this line down here. But actually, as I mentioned, this part can actually be factorized, but not easily in your head. Okay, but what I'm going to show you is another way. That's in your book, so if you're a bit slow, you copy from the book. But let me rub this out and show you another way to do it, which is actually better than using cubes. So let me show you another way to do this. And this bit here that I said can be factorized, and you'll see how or why that works. So let me clean all this out. Let's do it another way. So instead of making these cubes, if you can make a question to power 2 like this is better than doing this. This is preferable than this method. And in the book, they ask you to use this method. Okay, but this is actually better. If you can make a question to power 2, it's better to use that. But obviously, this is difference of squares. If this is plus, then it's not relevant. But if it's a subtraction sign here, this is the better method to use. So let's try it and see what happens here. And you'll see why it's better. So if the question can be changed to power 2, which this one can, a difference of square, this is the preferable method if you can do this. So 64 is 8 squared. A6 would be a cubed, wouldn't it? Like that. B squared would be b cubed, 2 3s are 6. So because we can make it as a difference of squares, this is the better way to do it. So now just write out your difference of squares. So remember, this is a squared minus b squared, which is a minus b, a plus b, like that. So let's write it out here. So this will give us a, which is 8a cubed, minus b, which is b cubed, and this is 8a cubed plus b cubed. Now you see what happened here. We have a difference of cubes and a sum of cubes. So let's clean out the formula. Cube, that would be bracket there. Okay, so what we're going to do now is these 2 bits here in yellow and blue. It's a little bit longer, but you actually get better factors. 8a cubed minus b cubed. So that would be 2a cubed minus b cubed for the yellow bit. And then the other bit is 8a cubed plus b cubed. But we'll have to make that 2a all cubed plus b cubed, like that. So this is just rewritten, but in cubes. So now you have a difference of cubes here and a sum of cubes here. So for the yellow bit, this would be 2a minus b. Then you would have 4a squared plus 2ab plus b squared for the yellow bit. So we are using the cube now. So that's the yellow part. Now we do the same for the blue. So 2a plus b and 4a squared minus 2ab plus b squared. That's finished. So now you see we actually got 4 factors. And that bit I told you before, that can't be factorized. These are the 2 factors here. So this is the preferable way to do it because you actually got 4 factors. 1, 2, 3, 4. Okay, but that's only if you can make it into a difference of square using this rule, a squared minus b squared, using this rule. So if you can do that, this is the preferable way to do this kind of question. But in the textbook, it shows you using cubes anyway. But I'll move along and you can copy that later because I'll post the video about this anyway. Okay, so example 3. Now in this question, we can factorize first. You see here, you've got y6 and y6. So you should factorize out the y6 first in this kind of question, like that. So you'd end up with x9 plus 125 z9. So let's make this into cubes, these 2 here. So you'll have y6, x9 is x cubed cubed, right? X cubed cubed plus 125 would be 5 cubed, z cubed all cubed. like that. So this bit is just rewritten here like that in terms of cubes. And now you have cubes, so now we can use your rule here. So we've got a cubed plus b cubed, which is a plus b, a squared minus ab plus b squared. And we'll write the answer in the top here. But you have a y6 here, right? So we should really put that first. y6, a plus b, that's x cubed plus 5z cubed. Like that. Then we've got a squared, so x3 to power 2 is x6, minus x cubed times 5z cubed, so 5x cubed z cubed. Put the number in front, okay, when you're writing out. Put your number and then your variables there. And then the last one, b squared. So 5 squared is 25. Z 2, 3, 6, Z6. Like that. Okay, so that's about all you can do with this question. So that's your answer there in green. Let's have a quick look at my answer key. 6. Yeah, it looks okay. Now in the next one, a little bit harder. Now you've got 4 terms. So we probably should be thinking about grouping in this case here. So let's look at the first 2 and then look at the second 2. Because you have 4 terms, I'm thinking maybe grouping works, grouping factorizing. So 4 terms here. So I'm thinking grouping may work. Let's see if the grouping method works. So I've got these 2 and I've got these 2 and I look for common factors here. And I'm going to find I've got 27 m cubed as the common factor here. We've got m cubed, but then 27 can come out as well. So we get 2p squared plus q squared here, like that. And then in this one, we've got 8n6 as the common factor. 8 and got n6, 8 and 16. So 8 is a common factor. Then we're left with q squared plus 2pq. 2p squared, sorry. But as you can see, now, let's use yellow. These are the same. 2p squared, q squared, 2p squared, q squared. So these are a common factor now. So grouping did actually work. So we'll take these 2 out to the front. 2p squared plus q squared. And you are left with 27m cubed plus 8n6. Like that. But the first term, there's nothing you can do with this first term here, this first factor. So this one's basically finished. There's nothing else to do here. But the second one, you can see now that we can do something with this here, this green one. So let's factorize this. So let's write the first one again. So 2p squared plus q squared. Now 27m cubed would be 3m all cubed, like that, plus 2n squared cubed, like that. So now we have our sum of cubes here. in yellow, in green rather, this one here. So now we will factorize this. So copy your other term, your other factor, 2p squared plus q squared. Now this will become 3m plus 2n squared. And then we will have 3m all squared, which will be 9m squared. So the plus, this will become minus 3m times 2n squared, 6mn squared. Plus the last term squared, which will be 4n4. I'm just using the rule in my head to write that out. So that looks like that's going to be finished. That's your answer there for that one. So that green one was all of this here. And this is your yellow one from the grouping up here. So that's your last line. This is your answer here. There, okay. But that one's showing in your book anyway. So take a look at that one if you can't follow. So in the questions, just use cubes, okay? So go to question 1 and write those as power 3 first. Can you do that? We've got 25 minutes. I'll help you with the first one and you can try a few yourself, okay? And then we'll do a few at the end. So M9 would be 3 cubed, right? So M9. So change everything to cubes in each question, and we have a plus. So this is the first thing you do. This is step 1. So do that first. And M9, well, if this is 3, it must be M3 inside. 3 times 3 is 9, okay? 512, what's that? 512, 8. Checking my answer key. 8, n cubed, 8 cubed, 512. So now it's written in terms of cubes. So I would write your formula next. You've got a cubed plus b cubed, a plus b, a squared minus ab plus b squared. So I recommend writing the equation next. This will be step 2. And then put your values in from the question. So we could write that again, I guess. So m cubed plus 8n cubed equals a plus b. So m cubed plus 8n as the first one. Then you've got a squared. So now you're squaring m cubed. So I'll write the whole working. M cubed squared minus ab, m cubed 8n plus 8n squared. So if you have a problem with this, just write the whole thing out and just follow the formula. That's all I'm doing. So we've got m cubed plus 8n, m cubed times m cubed will be m6 minus 8m cubed n plus 64n squared. So that's your answer there for the first one. You do some more, and I'll come back near the end. We'll do a couple as solutions, and then we'll do more on next week, and then we'll finish it next week. So that's your answer there. Okay, so copy that down, then I will move down the page a bit. And you can work in your workbook. I'll come back in about 10 or 15 minutes and we'll do some more solutions, okay? So I'll do question 2 for you and see what that looks like. So 216 as a cube would be 6. And we'll have m squared cubed minus n squared cubed, like that. Right, so you should have that set up. So we got the difference of cubes. So we can write our rule down. A cubed minus b cubed. A minus b. A squared plus ab plus b squared. Like that. And then just basically put your numbers in, right? So a is 6m squared minus b, which is n squared. A squared is 6m squared squared plus 6m squared times b, which is n squared, plus n squared squared, like that. So the last line I'll put down here. So 6m squared minus n squared. 6 squared is 36. Squared squared is n4 plus 6m squared n squared plus n4, like that there. Okay, so that's your final answer for 2. There. If you do more today, you'll have less to do next week. So by the end of the unit, you should have all of these solutions copied in your book somewhere or on your tablet. So when you come to the homework, and I probably will send you a homework quite soon, because I think we basically have covered all of the work which goes up to this section. So we should finish this unit next week with no problems. All right, so that's question 2. So for question 3, R6, 1000, S6. So we'll do a couple. So make these cubes. Well, let's write the rule first, probably better at the top. So a cubed, and we're using plus, so we'll have plus b cubed. So a plus b, a squared minus ab plus b squared. I recommend writing the rule every time because you're more likely to remember it if you have to write it every time. So we'll change this to R2 cubed plus 10 S2 cubed, like that. Okay, so that's your putting it into your sum of cubes. So now we have a plus b, r squared plus 10s squared. Then we got r squared squared minus r squared times 10s squared plus 10s squared squared, like that. Okay, so then we've got, it's basically finished. So r squared plus 10s squared, r squared squared is r4 minus 10 r squared s squared plus 100 s4, like that. So that's the answer there. So you keep working for a while and I'll do one or two more at the end there. So that's your answer there for that one. Okay, do question maybe 4 and 5 and we'll do some more next week. If you can do them easily, just work ahead a little bit. But you can stop about question 5 or 6 anyway. I'll come back in a few minutes. So we can do question 4. Okay, hopefully you've done it already. So K9 we'll make as K cubed minus 7 and 4 cubed. 7 cubes 343. So handy to remember those. So now we have a difference of cubes. So we're going to have K cubed minus 7n4, then K cubed squared plus K cubed times 7n4 plus 7n4 squared. So I'm just following the formula. So K cubed minus 7n4 K power 6 plus 7 K cubed n4 plus 49 and 2 4s are 8, power 8 at the end there. Okay, that's question 4. Yeah. Okay, if you have any questions, just ask, but we'll be doing more next week anyway. So that's question 4. How about maybe one more? What's this one? Oh. So now we have a common factor, all right? Common factor here will be J6. So let's take out J6 as a common factor here and here. So that should come out. So always look for common factors first, because they may cause you a problem when you're trying to use your rule. So J6 will have I12 plus 216 K9. So now we try to make these power 3 in the bracket in here. So J6, this will be I guess we should make it look like an I. So I4 cubed plus 6K cubed, like that. So now we have our power 3 here, which we wanted, and we have plus. So now we can use our rule. So J6 will have I4 plus 6K cubed. Now we'll have I4 squared minus I4 times 6k cubed plus 6k cubed squared, like that. Yeah, it takes a little while to write them out, but anyway, J6 I4 plus 6k cubed I8 minus 6 I4 k cubed plus 36 k6, like that. Let's check. 36 k6 I4. Yeah, looks okay. So that's your final answer there. Okay, for that one. I think we'll stop here. You can copy that down if you want to. I'll leave it there for a minute. But we'll stop here, and then next week we'll continue from question 6 here.